Welcome to day 5 of our daily fraction. Let's go ahead and highlight that. Put it back in. Okay, so let's get our beginning fraction. We have a total of 180 school days, so we have our total amount as our denominator, and we are currently on day 5. Okay, so let's look at that numerator of 5. Is 5 prime or composite? Well, 5, if we look at our prime number sieve, is prime. Now, the first 2 prime number days, we just made our groups, but yesterday we started that factorization, so let's keep working on that factorization. If you remember what we did yesterday, we're going to keep building on that. So we're going to do prime number factorization. We're going to find factors that are only prime numbers. So we want to start with our lowest ones: 2, 3, 5, 7, 11, and so on. Easiest one to start with is 2. Can I divide 180 by 2? Yes, it's even. Half of 180 is 90. Then let's see, we could also divide this by 2. Half of 9 I can't do. I can go down to 8. Half of 8, or half of 80, is 40. I'm left with 10. Half of 10 is 5. This ends in a 5, so I know 5 is a prime number. As long as the number down here is composite, you keep doing this. 5 times 9. 9 is composite, so we keep going. I can divide 9 by 3. 3 times 3. 3 is prime, so we're done. So our prime factorization for denominator, we start with our lowest factor, so we get 2 times 2. Factorization, we write it as a multiplication expression. Times, so we have 2 times 2 times 3 times 3 times 5. Since our numerator is prime, that's it. That is our prime factorization. So now we want to see, what do we have in common between our numerator and denominator? And that will tell us what our greatest common factor is. Well, we have 5 in both, so that means our greatest common factor is 5. That's what we'd be crossing out. We're left with 1 in the numerator, and then multiply these all together and you get your denominator. So let's go ahead and make our groups of 5. Remember, it doesn't matter what your groups look like. They do not have to match mine. But you don't want to group like this, because we can't have any shaded in with unshaded. We need to keep our shaded all together, because otherwise you're adding fractions within a fraction, and that just makes it more complicated than it needs to be. I'm using the idea that each row is made up of 10 squares, so if I cut them in half, half of 10 gives me 5 and 5. So I'm using a break apart or a decomposition of 10 to help me figure out a faster way to make groups. Any strategy you use to try to find a faster way to look for a pattern, that's all mathematical thinking. It's one of our standards of mathematical practice, is looking for patterns and making generalizations. Now, every square is in a group, so there's no remainder for sure. I have 2 groups of 5 in each row, so I can actually count up by 2's to find my new denominator. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. So my new denominator is 36. And how many groups are shaded in? Just 1. So I just did division with my model, actually putting things, dividing them into groups of 5, but I want to do it with my algorithm also. We want to divide by our greatest common factor, and it's always going to be the same because everything was in groups of 5, the whole thing and the shaded area. I didn't do different groups. I didn't do groups of 3 here and 5 over here. It's all the same. Okay, so let's start with our area model. So we have 180. Okay, so a close number to 18 would be 15, but I need that placeholder, so I'm going to try 30. 30 times 5, the placeholder moves it over. 3 times 5 is 15. Okay, and then I subtract. Numbers the same, zeros a game, more on top, no need to stop. So I don't have a remainder of 0. I want to keep going. This now goes up here. So 5 times 6 gives me 30. Numbers the same, zeros a game. So we're done. We don't have to do another one. We add our partial quotients here. 30 plus 6 is 36. Okay. So 5 times 1 is 5. We get 0. So our quotient here is 1. But no matter which way we would divide, we always want to check with our inverse operation. And our inverse operation says that I'm going to multiply my divisor times my quotient, and I'm going to add my remainder. But since my remainder is 0, and the identity property of addition says when you add 0 it stays the same, I don't need to take the time to add 0. So I'm just going to do divisor times quotient. So 36 times 5. 5 times 6 is 30. 5 times 3 is 15, plus 3 is 18. Check, because that matches my dividend of 180. I'm going to do the same thing here. My divisor of 5 times my quotient of 1 plus my remainder of 0. Again, the identity property of addition, I don't need to add that. But actually here, what I have is the identity property of multiplication. Whenever you multiply by 1, it stays the same. Okay, that is that identity property of multiplication. And that matches my dividend, so check. And my numerator is definitely 1. My denominator is definitely 36. Okay, now it's time to fill in our data collection page. Still in trimester 1, week 2. Today's date is 8/14/19, and our fraction is 1/36. Okay, let's go ahead and get out your number line. We did groups of 5. So let's look where it says 5. Let's go over to that first line, and it's 1/36 because that represents that first piece, that one piece. And if we look, that lines up perfectly with 5 180ths. So those are equivalent fraction because they show the same total amount. Okay, let's go ahead and put your number line away, erase your worksheet, and thank you for joining me.